In this video, we're going to look at some more examples that use properties of logs, including an example where we combine the terms of 3 ln of x minus 1/2 ln of 2 plus ln of z into a single log, an example where we rewrite ln of 2x cubed over square root of x as the sum or difference of logs, and an example where we solve 3 to the x equals 28 by rewriting in log form and then using the change of base formula. Also, I give a handy way to correctly remember the change of base formula. In this example, we're going to use properties of logs to rewrite 3 times the natural log of x minus 1/2 times the natural log of 2 plus the natural log of z by combining log terms into a single log. We start by moving the 3 back as an exponent because the exponent property says that if you have an exponent on the quantity being logged, it can be moved out in front, but likewise, if we have a coefficient in front, it can be moved back as an exponent. So the 3 gets moved back as an exponent. The 1/2 in the second term is applied to the 2, and the ln of z stays as is. Now, 2 to the 1/2 is the 1/2 power. That's the same as the square root. So we're going to replace that 2 to the 1/2 with the square root. Now we're going to apply the quotient rule on these two terms subtracted. We have natural log of x cubed minus natural log of the square root of 2 by the log property that says log of u minus log of v equals log of u over v. Here we get natural log of x cubed over square root of 2 using that quotient rule. And we still leave that plus ln of z as is. In the next step, however, we apply the product rule. We have the natural log of this quotient plus the natural log of z by the product rule that says log of u plus log of v equals log of the quantity u times v. We can combine those two and we get the natural log of x cubed over square root of 2 times z. That's our u and v from our product rule. Now we can write that final answer with the x cubed multiplied by z and put it all over the square root of 2. And the final answer is natural log of z times x cubed all over square root of 2. And keep in mind that we're taking log of that whole quantity. In this example, we're going to use the properties of logs to write log of a quantity as a sum, difference, or product of logs. We're starting with the natural log of the quantity 2x cubed divided by the square root of x. Now we have a log property that says if we have log of u divided by v, we can rewrite that as log of u minus log of v for any base log we have. So here we can rewrite this log of this quotient 2x cubed divided by square root of x as log of 2x cubed minus log of the square root of x. Now remember, the square root of x is x to the 1/2 power. So we're going to take that square root out and replace it with the 1/2. The next thing we're going to do is apply the product rule to that first log, the log of 2x cubed. We have a property that says the log of u, v, equals the log of u plus the log of v. So here we have the log of 2 times x cubed. We can write that as log of natural log of 2 plus the natural log of x cubed. And we still have that minus natural log of x to the 1/2 power. Now we can apply the exponent rule on the latter two logs. The log of x cubed allows us to rewrite it as 3 times the natural log of x because of the exponent rule for logs. So we move the 3 out front to get 3 times natural log of x. We can also move that 1/2 out front and we get 1/2 times the natural log of x. And our final answer is natural log of 2 plus 3 natural log of x minus 1/2 natural log of x. Here's a simple way to remember the change of base formula. The change of base formula says the log base a of v equals the log base b of v over the log base b of a, where b is any base you choose. Now typically you choose b as base 10 or base e because we have calculator keys for that. Well, here's how you remember it. In our original expression we have v and we have a. V is higher up than a, just looking at the expression, because a is the subscript or the base. So that means the log of v will be higher up or in the numerator. So it's going to be log base b of v over log base b of a. In this problem, we're going to solve the equation 3 to the x equals 28. And the way we're going to do this is we're going to rewrite it in log form, and then we're going to apply the change of base formula. Well, the equivalent log form of 3 to the x equals 28 is base 3 log of 28 equals x. Remember, the exponent is always opposite the log with respect to the equal sign. So our exponent is x, and the base of the exponential 3 will be the base of the log. So it's base 3 log, and the other quantity is 28. Now we don't have a base 3 log key on calculators, or we don't even have base 3 log tables. So we're going to apply the change of base formula, and we can write this in one of two different ways. We can write it as the base 10 log of 28 over the base 10 log of 3, or we can write it as the natural log of 28, which would be base e, over the base e log of 3. Again, we can write that as natural log. We do have calculator keys for both base 10 logs and natural logs, and if we put this into our calculator, we get 3.033 and so on. It's an irrational number that repeats forever, so we have to round it, and we get x equals 3.033 if we round it to 3 decimal places. This is about what we'd expect, because 3 to the third power is 27, and here we're solving the equation 3 to the x power equals 28. So we'd expect an exponent just a little bit bigger than 3.